The transcript to this video has several YouTube video links in it. You may enjoy looking at them at your pleasure. Last lecture, we learned to do mathematics with vectors. And in particular, for most vector manipulation, you can separately analyze the various components. They are independent. In the model that we're going to do for projectile motion, the same thing happens. One can separately analyze the horizontal motion and the vertical motion. The horizontal motion will be motion with constant velocity, and the vertical motion is motion with constant acceleration. Now there are 4 questions you might ask. What do I mean when I say that these decouple? Why is it true? When is it true? And how can I make use of this? For the first question, I mean that when I throw a ball into the air, then in our model, the x position just evolves as if the ball was sliding along a frictionless surface, and the y component evolves just as if it was thrown straight up in the air. Mathematically, we write that the horizontal motion follows our equations of constant speed, and the velocity is constant. Here, x naught is our initial position, vx naught is our initial velocity. I sometimes instead use xi instead of x naught, or vxi instead of vx naught. These mean the same thing. Right? The important thing is not the symbol, the important thing is the concept. It's initial position, initial speed. The vertical motion is motion with constant acceleration, the same as when you just drop a rock off a bridge. These are what the equation will look like if I take the vertical direction to be positive y. So gravity here is a force acting downwards. And as we've already discussed, g equals 9.8 meters per second squared. It's the acceleration due to gravity. Okay, so this is the model. Why on earth should this be true? All right, and at the root of this phenomena is gravity. As we'll discuss later, gravity pulls towards the center of the Earth. It does not care about horizontal motion. Gravity only affects the vertical component of motion. And that is why the two parts of the motion, horizontal and vertical, separate. It's a feature of gravity. Now, if there are any other forces acting on the system, this will not be true. So, for example, air resistance. So here's a little video clip watching some badminton.
Hey guys, welcome back to another video. I know it's been a really long while.
So the thing I want you to notice in this video is that when this badminton player here hits the birdie, it does a trajectory which looks almost straight line here, curves over, and drops down. Okay? This is very different than what our model of projectile motion gives. As I'll discuss in the next video, our model of projectile motion actually gives a parabolic trajectory, which is symmetric on the way up and the way down. And so badminton is not well described by this model. And the reason is that the forces from air are important in badminton. In fact, the shuttlecock is designed to make those forces large. It's a light object with a large surface area, and the shape also has important features for the aerodynamics. On the other hand, there are many projectiles which air drag is less important. Here's an example which does show the beautiful parabolic type trajectory that we're going to find within our model. See how the trajectory is symmetric between the way up and the way down? And if you looked at how fast it was moving in the x direction, that was a constant. It was moving at constant speed. On the other hand, in the y direction, you can tell by looking at the spacing between the images in this strobe that they're closer together up near the top of the trajectory, so the vertical motion is slower there, and they're farther apart during the bottom, so the vertical motion is faster there. It's motion with constant acceleration. So, if indeed the horizontal and vertical motion of a moving object decouple, if I dropped this ball and threw it horizontally, it should hit the ground at exactly the same time. In fact, a more dramatic case of this is if I take a gun and I shoot a gun and I drop a bullet, the two bullets will hit the ground at the same time. Here's a little demo. So to summarize, when you can neglect air resistance, our model of projectile motion is good, and the vertical and horizontal motions decouple. In the next video, I'll show you how to apply this model. I want to give a shout out to the great YouTube videos that I borrowed parts from for this lecture. Please check them out in the transcript.